Alright, picture this. You're flying on a spaceship to Mars. No big deal, right?
This isn't normal! What do you mean this isn't normal? This is way worse!
But seriously, what if I told you that even though we can go to the moon, scientists are working on designing and building gas stations in space? Like literal gas stations, but without all of these sketchy bathrooms and the day-old hot dogs. So the big question you may be asking is, why? Well, as of today, every rocket that we launch in space has to carry all of its own fuel, which limits how far it can go as well as how much cargo it can take. To truly unlock deep space, we have to be able to take advantage of this next generation of heavy lift rockets like Starship. And to do that, we can't launch with a full tank of fuel. We have to build the universe's first space gas station because it's the only way to haul enough stuff to actually live on Mars. This whole refueling thing is the golden ticket to be able to turn the moon and Mars from a quick road trip to a permanent vacation spot. Alright, we've been putting humans in space since the 1960s and we've learned a ton. For instance, did you know that space is dead silent because there's no air? Or that the sun is so gigantic that it makes up about 99% of everything in our solar system? Its gravitational pull is so big that it basically keeps everything in orbit, including us. So to get why we need a refueling station, you gotta know that gravity creates these organized zones around Earth, and let's think about them like a basketball court. First up, LEO, which stands for Low Earth Orbit. Think of it like the paint. It's the fast lane, super crowded. Stuff here like Starlink flies about 17,000 miles per hour and circles the planet in like 90 minutes. Next is MEO, or Mid-Earth Orbit. That's the mid-range area. It's the mid-range zone where all the vital GPS satellites hang out. They take about half a day or 12 hours to get around. Finally, my favorite, GEO, which stands for Geosynchronous Orbit. This is like the 3-point line area or beyond. We call this the parking spot because these satellites move at the same speed Earth spins. For example, if we put a TV satellite in LEO, it would spin out of sight in minutes. GEO lets them constantly cover a huge area for weather and TV. And any space junk left up in this zone, it could float for hundreds or thousands of years. And that is a huge problem when we start talking about reducing our footprint for the next generations of humans. So if a satellite runs out of fuel, then it just becomes space trash, which we have about 10,000 satellites up there right now working for us, so keeping the lanes clear is a big deal. Companies like Orbit Fab or Astroscale are working on building this whole space infrastructure for us. You've heard of a tugboat on Earth, right? Well, they have a similar concept in space. They want to have space tugs that can dock with these satellites. And basically what they'll do is they'll act either as a new engine and push the satellite out of the way, or act as a fuel tanker and give the satellite enough fuel that way it can perform its own maneuver to get out of the way. Okay, so now for the real brain teaser, Mars. So like I mentioned earlier, we're gonna need those really big rockets to be refueled in space, which normally isn't a problem, except for with the super cold temperatures, the fuel tends to form one big floating bubble, which can definitely screw up the pumps. Since engineers can't use gravity, they use something called a capillary force to hack the system. Think about when you put a straw in water. That water always creeps up to the sides a little, right? That's capillary force. Engineers build tiny channels inside the tanks that trick the liquid fuel into sticking to the walls and flowing right to the pump, like one big giant sponge. For an extra nudge, they do what they call a settle burn. The tanker fires its tiny engines for a few seconds to create a little bit of fake gravity, forcing the liquid to the bottom so the gas bubble can safely escape. It's the opposite of filling up your car, where gravity does all of the work. NASA has actually been pulling off this neat trick since 1966, when the Atlas Centaur AC-9 mission first restarted an engine using this method. Once we master refueling, it's game over. Satellites will be able to make crazy maneuvers, and we can carry heavy science gear to faraway places like Jupiter's moons. Think of a standard satellite like an old cell phone that you have that you can't replace a battery on, as opposed to this new standard of satellite where you're going to be able to recharge it every few years just by pulling up to a refueling station. That's how space goes from being a one-time road trip to a commuter highway. Honestly, this engineering stuff is huge, but it kind of makes you think, Should we be spending all this time and cash in building refueling stations so that we can get to Mars? Or should we be focusing all those resources right here on Earth, where we already have problems, where we need to improve mass transportation or increase access to reliable transportation? Let me know what you think about down in the comments. Alright, if you enjoyed breaking down this amazing engineering challenge, go ahead and hit the like and subscribe button. And if you want to see more fun videos like this, go ahead and click that one right there. As always, I'm Neil, and I'll see you on the next one. Peace.